In this video, we're going to use the sum and difference identities for sine and cosine to solve some drill and grill style homework type problems. So the first example is one where what we need to recognize is that the difference identity for sine looks like this. The sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. And what we want to identify is that this expression that we're looking at right here follows this exact pattern, with alpha equaling 137 degrees and beta equaling 47 degrees. So if we let alpha equal 137 degrees and we let beta equal 47 degrees, then what we know is that we can take the sine of 137 degrees times the cosine of 47 degrees minus the cosine of 137 degrees times the sine of 47 degrees, and we can rewrite this using the sine function. We can do the sine of 137 degrees minus 47 degrees, and this difference simplifies to 90 degrees. And then we just need to remember where that is on the unit circle. So I draw in my horrible looking unit circle, and I recognize that 90 degrees puts me in the top position where the ordered pair is x is 0, y is 1. And I recognize that on the unit circle, the y coordinate is the sine value. So sine of 90 degrees simplifies to 1. So in this example, we're given obtuse angles. So angles that are between 90 degrees and 180 degrees, with sine of alpha equaling this ratio, side ratio here, and the cosine of beta equaling this side ratio here. So what we want to recognize is that for to solve the sine of alpha minus beta, we can use the difference identity for the sine function, which is just going to be sine alpha cosine beta minus cosine alpha sine beta. So we would need to be able to calculate these values, sine alpha and cosine beta, cosine alpha, sine beta. And we're going to need to calculate that for angles alpha and for angle beta. So what they've told us is that we have two obtuse angles. So draw a picture of the first one. So alpha is going to be an obtuse angle. So between 90 degrees and 180 degrees, he's going to be sitting somewhere in quadrant 2, and he's going to be establishing, there's going to be a point established on some circle in quadrant 2. That's going to be the terminal side of the angle alpha. And we're given some information here. We're told that the sine of alpha is 28 over 53, but we know that the sine function is defined in the xy plane to be the ratio y over r, where r is just the radius of the circle or the hypotenuse of this right triangle. So what we're given is that y is 28 and r is 53. So I can say, hey, I don't know what the x coordinate is. I know it will be negative because I'm in quadrant 2 because of the obtuse angle. I know the y coordinate is 28, and I know the hypotenuse or radius right here is 53 units. I know that the height of this triangle is 28 units, and x will be the signed width, which means I can use the Pythagorean theorem to calculate x. I know that x squared plus y squared, which is 28, is going to equal r squared, which is 53 squared. And so subtracting that 28 off of both sides, we're going to get x squared is 53 squared minus 28 squared. And then we would take the square root of both sides, but we're going to need the negative square root because we're in quadrant 2. So we're going to get square root of 53 squared minus 28 squared with the negative sign in front of it because of the quadrant that we're in. And if we crunch this in a calculator, this is going to kick out a negative 45. So the x-coordinate's negative 45. So right now I know everything about alpha that I need to know. I know that x is equal to negative 45. I know that the y value is 28. And I know that the radius r is 53, which means I can calculate the sine of alpha, which is just the y-coordinate over the radius. And I'm also able to calculate the cosine of alpha, which is just the x-coordinate over the radius. And that's just using the definitions for cosine and sine, right? Cosine of an angle is defined to be x over r, and sine of an angle is defined to be the ratio y over r. And I need to get the same information cataloged for beta so that I can sub it into this expression. So I have another obtuse angle, beta, sitting somewhere in quadrant 2. And this time I'm told it's the cosine, and I know that cosine is the ratio x over r. So the negative sign here tells me I have an x-coordinate of negative 13. I don't know the y-coordinate, but I do know this radius is 85. And again, we can use the Pythagorean theorem to calculate y, because y is the height of this right triangle, and x is the signed width of this right triangle. So we get negative 13 squared plus y squared equals 85 quantity squared, which means that y is going to equal the positive square root of 85 squared. We'll have subtracted this negative 13 squared from both sides. And if we pop this into a calculator, we get 84. And so now we know everything about beta that we need to know. We know that x is equal to negative 13. We got that from the side ratio. We calculated the value of y to be 84, and the radius is the 85 units, which means we can calculate the sine of beta, because it's just the ratio y-coordinate over x-coordinate, and we can calculate the cosine of beta, which is just the x-coordinate over the radius. And then those can be substituted in here. I didn't leave myself much room to do that substitution, so that's not the greatest thing. I'll give myself a little more room. So this is going to equal sine of alpha is 28 over 53 times cosine of beta, which is negative 13 over 85, minus, and then we have cosine of alpha, which is right here, negative 45 over 53, times sine of beta, which is right here, 84 over 85. And if we simplify this whole mess in a calculator and put it all over the common denominator, we're going to get 2937 over 4505. That's just the common denominator coming from taking this product. And then we'll get negative 13 times 28. We have a double negation. We could actually rewrite this as a plusy and add 45 times 84 to negative 13 times 28. So sliding through to the next slide, we can calculate the cosine of alpha plus beta. And notice that we can use the work that we already did on the previous slide. We calculated all of the side ratios already. We did this work. So now it's just a matter of looking at the cosine of alpha minus beta and using the difference identity for the cosine function. So we get cosine alpha, cosine beta, and it's minus, so it's going to be plus right here, and then it's going to be sine alpha, sine beta, and then it's just a matter of going in and plugging in the values that we already calculated. Cosine of alpha is negative 45 over 53. Cosine beta is right here. It's negative 13 over 85. Plus sine alpha we already calculated. It's 28 over 53 times sine of beta, which we already calculated to be 84 over 85. And then it's just a matter of multiplying these two numbers together to get your common denominator. just double checking here. Oop, right here I made a mistake. This calculation should have been, I just realized I put the wrong number on this side. This calculation should have been 3416. So need to make a correction if you're taking notes. That I put the wrong number there. This product is going to be the same as it was before. It's still going to be the 4505, and when I take this product plus this product, I'm going to get 2937. I put that number accidentally for the wrong function. So now sliding through to the next slide. So to get the tangent, what we want to recognize is that we have a ratio identity. We know that the tangent of any angle is just equal to the sine of that angle divided by the cosine of that angle. And we've already calculated the sine of alpha minus beta and the cosine of alpha minus beta, which means that the tangent of alpha minus beta is just going to be the ratio sine of alpha minus beta over cosine of alpha minus beta. And we already have that ratio calculated. It's going to be 3416 over 4505 divided by, there's the sine, divided by what? Divided by 2937 over 4505. And our denominators match, so they're going to divide out and give us a 1. So this ratio is just going to be 3416 over this numerator over the other numerator, 2937.